Hello everyone. Let's learn a new topic from non-uniform flow in a channel. It's about hydraulic jump, how it's formed, and what are the uses of hydraulic jump and different type of hydraulic jump as per USBI. From let's learn about hydraulic jump. But first we have to learn about what are the depth of critical, what are the different type of depth. Here one is a Y1 and Y2. The depth Y1 is a less than a critical depth Y, and the depth Y2 is a greater than the critical depth Y. The depth y is known as initial depth, and depth y2 is known as a sequent depth. Both depths together are commonly known as a conjugate depth. Conjugate depths are different than alternative depths. In the conjugate depth, specific forces F is the same, while the alternate depth specific energy is same. When the depth of flow is less than the critical depth, the flow is measured called as shooting flow or subcritical flow. When the depth of flow is greater than a critical depth, the flow is called a streaming flow or a subcritical flow. The shooting flow is an unstable type of flow and does not continue in the downstream side, the flow transfer. The unstable shooting flow to the stable streaming flow is called as a hydraulic jump. What is hydraulic jump? The unstable shooting flow to the stable streaming flow is called as a hydraulic jump or standing wave. Hydraulic jump Hydraulic jump is defined as sudden turbulent passage of water from subcritical state. The depth of subcritical flow is less than compared to the depth of supercritical flow is less than compared to subcritical flow. So when flow changes from supercritical to subcritical from a small length of channel, sudden increase of depth takes place. This phenomenon is known as a hydraulic jump. A hydraulic jump will form when water moving at a supercritical velocity. In relatively shallow streams strikes water having a relatively large depth of subcritical velocity. A hydraulic jump generally occurs at first a canal below regulating sluices at the foot of spillway at a place where a steep channel bottom slope suddenly change to a flat slope. Assumptions in an analysis of hydraulic jump. It is assumed that that before and after the jump formation, the flow is uniform. The pressure distribution is hydrostatic. The length of the jump is small, so that the loss due to the friction on the channel floor are small and hence neglected. And third is a channel flow is a horizontal, or the slope is so gentle that the weight component of a water mass is small and neglected. The place where the hydraulic jump takes place, a lot of energy of a flowing liquid is dissipated. This hydraulic jump is said to be dissipated of surplus energy of water. After the hydraulic jump, water flows with a great depth but with a less velocity. What are the uses of hydraulic jump? Now let's learn about what are the uses of hydraulic jump. How we can use, why we can use. To increase the depth of water in a canal for irrigation purpose, it brings the tailwater back by sluice and increases the discharge. Third, it dissipates the energy of water flowing over spillways and control the erosion of downstream slide. And fourth, due to hydraulic jump, depth of water increase on the apron of hydraulic structures. Depth of water increase on hydraulic structures and uplift pressure is balanced. First for canal irrigation purpose, second for tailwater back by sluice and dissipate the energy, and third is for balance of uplift pressure. Fifth, At the place of hydraulic jump, chemical can be easily mixed with water due to turbulence. And 6 is a hydraulic jump dissipates the energy to the great extent, and it can be used as an ideal energy dissipation device. Now, based on the value of Froude's number of incoming flow, US Bureau of Reclamation (USBR) has classified five types of hydraulic jumps. First is an undular jump. The Froude number value of Froude number is between 1 to 1.7. Liquid surface shows undulation of gradually decreasing size. It's called as a undular jump. Second is a weak jump. Value of Froude number lies between 1.7 to 2.5. It's called as a weak jump. Number of small rollers appears on the surface of the jump, and the downstream liquid surface remains smooth. The energy loss in the jump is a low. Third is the oscillating jump. Oscillating jump. Froude's numbers, William Froude numbers lies between 2.5 to 4.5. The oscillating jump enters the jump bottom and oscillates the free surface. Each oscillation produces a large wave, which may damage the bed and banks while traveling miles downstream. That's an oscillating jump. Fourth is a steady jump. Value of Froude number is 4.5 to 9.0. The value, the jump is a very stabilized, and energy dissipation ranges from 45 to 70%. Fifth is a strong jump. Froude numbers value are greater than 9. The surface downstream of the jump is rough and energy dissipate may be up to 85%. Here are some figures that shows the what is hydraulic jump, where Froude number is a 1 to 1.7, big jump is 1.7 to 2.5. This is a jump. Oscillating jump. This is an example of oscillating jump, where Froude numbers value is 2.5 to 4.5. But this is a steady jump, where Froude number is a 4.5 to 9, and that is a strong jump. Froude number is 2.5 greater than, sorry, 9.5, 9.